Alright, let's look at an example for finding scalar potentials. Alright, so let's say a force field is given to be 2x cosine squared of y, comma, negative quantity x squared plus 1 sine of 2y. Alright, so let's do that. Alright, so a gradient of phi is partial of phi with respect to x, comma, partial of phi with respect to y, and this is going to be equal to negative of that, so it's going to be a negative 2x cosine of 2y, and then you have a positive x squared plus 1 quantity times sine of 2y. Right? So let's take the antiderivative to find phi. So if you take the antiderivative of negative 2x cosine squared of y with respect to x, it's going to be negative. Right, antiderivative of 2x would be x squared. Right, then cosine squared of y is considered to be constant. So plus you could have some function of y, so you put g of y. So this is still unknown. Right, and then we take the partial of what we found with respect to y. So we can use the second clue there. So so this is a partial with respect to y. So it's going to be negative x squared. It's just going to be a constant. So it's going to be put 2 in front. So it's a general power rule. Cosine of y. Then you would have to multiply by the derivative of cosine, which would be negative sine of y. Then we have derivative of g, so I'll just write g prime of y. Alright, then we have to do a little bit of trig identity. So here you have a negative sign and negative sign cancel out there. Alright, then you see that here 2 sine cosine is so this guy is the same thing as sine of 2y. Right? So this is going to simplify to x squared sine of 2y plus g prime of y. Right? So we can match this up with this guy right here. So this guy is supposed to be equal to that guy right there. Right? So we're going to match those guys up. Alright. Then you notice that here you have a x squared sine of 2y, x squared sine of 2y, so those are matched up. But we still have 1 times sine of 2y, so that's got to be that guy. So we know that this tells us that the g prime of y is equal to sine of 2y. Alright, so then we can find out find g of y by taking the antiderivative of that guy. So you have take the antiderivative of sine of 2y with respect to y. Right? So that will be let's see, antiderivative of sine is negative cosine and 2y, then you would have to divide by 2 because it's 2y, so divide by 2. Right? Then plus some constant c. Right? So therefore we just found phi function. So phi is going to be equal to negative x squared cosine squared of y, and a g of y came out to be negative 1/2 cosine of 2y, and then plus some constant c. Right? Right. So that's the scalar potential for this given vector field, vector function. All right. That's it. I hope that this was clear.